Assalamualaikum and good afternoon everyone, and thank you. My name is Hariz bin AMIRUDDIN, and together with my team members, we are presenting on Code of Ethics in Action, which is ethical versus unethical computing practices. So today, the following are the team members for this task. So we have NURUL, BALQIS, HADI, followed by ARSHADAH, FARHANA, IZZAT, and also me myself, Amirul, Hariz bin AMIRUDDIN. So all of us contributed equally to do some research, design the slide presentation, also prepare for this topic. So for this presentation, I will be starting by covering the introduction and setting context, and the following slides will followed by AZMAN, BALQIS, and lastly we'll close the presentation from ARSHADAH. So as developers build modern applications, um, they face significant ethical challenges, which particularly around building secure systems. The key issues revolve around authentication and also data security. When these are handled poorly through unethical coding practices, which both users and also organizations can suffer serious consequences. So for this presentation, we are going to use the PAPA framework, which stands for privacy, accuracy, property, and also accessibility, along with the broader big PAPA concepts to analyze the ethical versus unethical issues. By following ethical guidelines in coding, developers can not only protect individual users but also safeguard the organization and contribute positively to the wider technology community. Okay, so for the next one, the following are the real world impact of unethical practice. So when developers take shortcuts in security, such as weak authentication or poor data handling, the consequences can be severe. So the following, the first impact of unethical practice is privacy violation, which insecure methods will expose sensitive user data and also leads to the data breaches and identity theft. Number two, legal and financial fallout. The company may face lawsuits, heavy fines, and also significant financial losses due to the breaches. Number three, erosion of trust. Users lose confidence in the platform when they feel their data is not safe, which will reduce engagement and also damage the company's reputation. And lastly, societal impact. On a larger scale, repeated unethical practices will erode public confidence in technology overall, and not by that, it will also slow the digital innovation and growth. So I will say that these are not just theory risks, but it also happens in real life when security is neglected. So with that, I have covered the title, theme, introduction, the objective, and also the serious impacts of unethical practices. For the next slide, I will hand over to the next presenter, IRFAN, who will dive into the PAPA framework and also Big PAPA framework in detail.
Okay, so for the PAPA framework, we have the first one is privacy. So for bad code, hardworking password expose sensitive data. And the second one is good code, use password hashing, encryption, and MFA to protect user data. And the last one is impact, protect user privacy and prevent unauthorized access. um, so for the second one is accuracy. Bad code, skip input validation that allow unauthorized access. Good code, use OAuth or JWT to validate credential properly. For impact, ensure correct unauthorized and prevent unauthorized access. So for the property, bad code, store user data insecurely that violate user ownership. Good code use encrypted storage and hash password to protect data. Impact respect user property and secure data. And for the last one is accessibility. Bad code with authentication expose data to unauthorized user. Good code implement two-factor authentication and RBAC to control the access. And the last one is impact ensure secure access for unauthorized user only. So for the big papa, we have two, which is organizational and societal impact. For organizational impact, bad code insecure authentication lead to data breaches and legal consequences. Good code secure coding practice help in protecting user data and avoid reputation damage. And for the impact is build trust, compliance, and reputation for the company. And for the societal impact, bad code, data breaches, and poor security erode to public trust. Good code, ethical coding create a secure digital ecosystem in technology environment. And the last one, impact, encourage innovation and grow in technology plus maintaining public trust. So for the next slide, I will pass to the next presenter.
Hi, I will present the unethical coding example. And for this slide, this demonstrate an example of unethical programming practice where user passwords are stored in plain text in the given where when a user registers, their password is saved exactly as entered without any form of protection, such as encrypt or hashing. Although this approach may appear simple and functional, it creates a serious security vulnerability because sensitive user information is not adequately protected. Next slide. So why this code is unethical? This code is considered unethical because it stores user password in plain text without applying any security measure. Passwords are classified as highly sensitive personal data and should never be stored in a readable format. Without encrypt or hashing, anyone who gains unauthorized access to the system, whether internally or externally, can easily view and misuse user password. Next slide. For the potential impact, if this system is not compromised, attackers can immediately access all stored passwords. This may lead to identity theft, financial loss, or unauthorized access to other online accounts, especially if users reuse the same password across multiple platforms. In addition, such security failure can damage the organization reputation and result in significant loss of user trust. Next slide. For ethical issue, from an ethical standpoint, this coding practice failed to protect user from foreseeable and preventable harm. It reflects a lack of professionalism and responsibility as developers are expected to anticipate security risks and implement appropriate safeguards. Ignoring basic security practice such as hashing password also violate the principle of privacy and accountability in software development. For the next slide, ACM code and of ethic reference. According to ACM Code of Ethic and Professional Conduct 2018, Principle 1.6 state that computing professional should respect the privacy of others and honor confidentiality. By storing password in plain text, this code fails to respect user privacy and does not ensure the confidentiality of sensitive information. Therefore, this practice directly contradicts the ethical responsibilities outlined by ACM. For the next slide. for IEEE Code of Ethics reference. Furthermore, the IEEE Code of Ethics Principle 1 emphasizes the importance of holding paramount the safety, health, and welfare of the public. Exposure user credential through insecure coding practice put user at risk of serious harm. As the result, this code failed to uphold professional responsibility and does not meet the ethical standard required to protect public welfare. Next, I will pass to the next person. Thank you.
Okay, so I will present the fixed code for unethical coding. Here is a screenshot of the fixed code for the unethical coding just now. So on this code, we can see there are some new line code that was added. Next slide. Okay, so on this slide is details of which line was unethical and what is the fixed version and also why it need to be fixed. So I will start for the storage part, and the line of the unethical code, which is the username equal to password and the plain text. So the fixed version of code is username equal to salt underscore hash, and also there is a salt plus hash password. Why this new code was added? Because there is never store the readable password. Hash is the one way that can reverse to original password. So for the second part, which is the salt generation, there is none in the unethical code before. So it was added to the new coding, which is line salt equal to os.urandom32. 32, which is mean the byte random salt. And why? The reason is because of the unique random sort per user prevents the rainbow tables, and also it makes the identical password stored differently. So for the hashing part, there is none in the unethical code before. So the line was added, which is the hashlib.pbkdf2 underscore hashmag, and there is a SHA-256 password encoded, and also the salt 600,000. So this line was added because of the user's PBKDF2 is a key derivation function, and also the 600,000 actually was recommended to add in for the password code, and also it to resist the brute force attacks on the GPUs. Okay, so the fourth one is the storage format, which is the code before is a plain string, and for the fixed version is a hex encoded salt plus hash. And the reason is to easy it and the reason is for easy to store or retrieve the securely in the database. The last one, which is the verification, uh, the code before is equals to password, and for the fixed version is the recompute hash with store, sort, and compare. So this is because of to same secure process, which is no plain text ever exposed. So I think that's all from our group. Thank you.